Sequences, probability, and counting theory. The question of how many ways can you do something and what is the probability this will happen, we all have an intuitive knowledge of it, and we'll get back to that in a second. See, counting theory started way back in 4000 BC with the Sumerians. And then in the mid-1500s, a mathematician by the name of Cardano investigated it. But formally, around the mid-1600s, two mathematicians, Fermat and Pascal, they went ahead and took a look at probability because they were looking at gambling. Now, again, coming back to you and I already have an intuitive way of looking at probability and counting theory. We have some understanding of it. We start with just the very beginning by saying, how about this hypothetical situation? How many outfits are possible? Just suppose, I was choosing from any one of 4 shirts. I mean, I could choose from this here shirt, this here shirt. Now, that's a great one. This here shirt. What do you think of this one? Or even this here shirt. And I wanted to pair them up with any one of 2 sweatshirts, like this one here, right there. Or this one right here. I'll show you. This one right here. How many outfits are possible? Well, excuse me. Well, I can take any of the 4 shirts and pair them with any one of the 2 sweatshirts, and that's 8 outfits. So we're looking at a basic fundamental counting principle. It's actually the fundamental multiplication principle. Let's take a look at some examples that are probably, although the numbers may not be, the concept's quite familiar with you. Now, for example, you have a phone. You want to enter your phone code. You have 10 digits. You have 4 different numbers you can put in. Any one of the 10 digits that you enter for the first number could be paired with any one of the 10 digits that you enter for the second number, and so on. And there's 1,000 different phone codes you could enter. How about a basketball lineup? 5 players on a team. And how many ways can you create a basketball lineup? If 5 players could be the center, and then that leaves 4 players to be the forward, and so on, there's 120 possible lineups. Now, if you had, say, 12 players on the basketball team altogether, which you do, at least in the NBA, you have 95,000 different lineups. And baseball, oh, don't get me started. For the 26 people on the team, filling a lineup of 9 players, that's over 1 trillion. Now, how about probability? Do you have a sense of probability? You know, when you toss a coin, you can get a head or a tail. So the probability of getting a head is 1/2. What is the probability of tossing a coin 20 times and getting a tail every time? Well, you say to yourself, gosh, the first time I toss, the probability of getting a tail is 1/2. The second time is 1/2. And so I'm really taking 1/2 and multiplying it to itself 20 times. And the result, well, that chance is about 1 in a million, a little even less of odds than that. How about the probability that you're going to toss a single die 8 times, and get 6s every single time? Tossing all 8 tosses and their 6s would be a 6 times a 6, a total of 8 times, which is basically about 1 in 1.7 million. Welcome to the world of probability, counting theory, and sequences.